Let's talk about vectors. Vectors are directed line segments. So they're not infinitely long lines necessarily. They're actually called half lines sometimes because we have a starting point and then they go off in a direction and they go forever on that direction. So when we've got vectors, we tend to call them V's sometimes and put a little arrow over them. And once in a while, we use I and J as the coordinates. So if I have something like 2I plus 1j, what I would do is I would say this vector starts at the origin. And they all can start at the origin, believe it or not. And this would be the x direction. This is the horizontal. And this one is the vertical. So if I'm going to talk about vector v, I go out 2 units from the origin. I go up 1 unit from the origin, and I'm right here. I connect the dots from the origin out to there, put an arrow there, and so this is my vector v. Now, I talk about vectors in a couple of ways. One is I talk about the direction. Now, the direction can be done with angles. It can be done talking about it this way, whatever. We also sometimes talk about the magnitude of the vector. In other words, how long is it? Now this one, I've got this stopped right here, so I'm not making it go forever. This one I was saying went forever. This one is not. This is a particular length. So from 0, 0 out to 2, 1, how far is it? Well, the magnitude is given, it looks like double absolute values. And it is defined this way. It's the square root of the x part squared, or the I part, and then the y part. So it's just a distance formula. So this one's going to be the square root of 4 plus 1, or the square root of 5. So that's the magnitude. Okay? If you've got a vector v, and you want to have a unit vector in the same direction, so unit vector for v, then it's in the same direction as v, but it isn't v, so it's just in the same direction. Then what we would do is we would take our v value, vector v, and we would divide it by its magnitude. So we've got 2 over the square root of 5, I, plus 1 over the square root of 5, j, and there's a unit vector in the same direction as v. So there are a couple of definitions. Now, if you want to go this way, you're going to have a negative in the I part and a positive in the j part. I is the x and j is the y. Why they used I and j instead of x and y? Good question. It just kind of is a different mode. If you want both of them negative, you'll end up in quadrant 3. Both of these negative, or x positive and y negative, or I positive and j negative, you end up in the 4th quadrant. Okay, now, any vector that goes the same direction and the same length as v is considered equal to v. So if I started a vector right here, and I went out 2 units and up 1, and my drawing doesn't prove this out necessarily, but this is exactly equal to that. So those 2 vectors are equal. So v equals u if they both have the same direction and magnitude. Okay, so and magnitude. Some other things about vectors. Anytime you want to, you can add vectors, you can subtract vectors, you can do some styles of multiplication and some styles of division. So algebra of vectors. let's say we've got a vector v. I'll use the same one I just had. It's 2i plus 1j. Now let me give you an alternative way to write that. Sometimes people use less than and greater than type symbols. They aren't really, but this is not an interval or a point. It is a vector because of those. So if I've got that one, and let's say I've got a vector that I'm going to call w, and they usually are listed in the latter part of the alphabet, but let's say this one is minus I plus 3j. Well, this one would be given this way. It would be minus 1 and 3. So if I wanted to take v plus w, then I just add the components. So the I components, 2 plus a minus 1 is 1. 1 plus 3 is 4. So there is my resultant vector, my addition of two vectors. I could subtract. I could take v and subtract w. That would give me 2 subtract minus 1, that's 3. 1 subtract 3 is minus 2. So here's the subtraction of vectors. Now there's a way to multiply. It's called scalar multiplication. So scalar multiplication, and that is multiplying by a constant. So let's take 5 times v. That's a scalar. It's called a scalar. So we have 5 times our 2, 1, and that gives us 10, 5. So it just multiplies the length of the vector actually by 5. So that is what's called scalar multiplication. Now there are some other kinds of multiplication. We aren't going to really deal with that right now. This is just an introduction. So how do you write a vector given a couple of points? Let's say that we are given 2 points. Given a point minus 1, 6 and 4, 8. So what's the vector? That's the question. Well, I probably need to identify where I start. So let's say I start here and I end here, okay? So if I start there and end at 4, 8, then the way that I would write my vector is I would start at I would do the end and the beginning, so end to beginning. So I take end point minus beginning point and put it in vector form. So here's what I'd get. I'd get 4 subtract negative 1, 8 subtract 6. So that is 5, and this is 2. So there's the vector, 5, 2. Now that is the same length and direction as this segment from here to here. All right? So that is an equivalent vector. You could actually put it at minus 1, 6 and run it to 4, 8, but this is an equal vector. So how long is this vector? So what's the magnitude? You've done distance between points before, that's the same thing. Magnitude of this is 25 plus 4 under a radical. Square that, throw them together. You get square root of 29. So there's the magnitude, okay? Now, what if you want to find the direction? You might want to find it in terms of angles. So what's the angle of this vector? Well, let's take a look at this. If we have a graph and we've got 5 and 2, and it's right here. So we've got that. What is this angle? Angle theta. Well, I know I've got 2 here and I've got 5 there, and I use trig to do this. So I know that the tangent is the y value over the x value. So the tangent of theta is equal to 2 over 5. So theta is equal to the arctan of 2 over 5. So if I want theta, I could say that it's the arctan of 2 over 5. Now you can use angles in degrees or radians, but there's your angle. So if you want to know the angle, you can do that. Here's the length, and there's the vector. So that's a little bit of information about vectors. Now let me go back to this. When we add vectors, they add, addition takes place this way from a visual point of view. Addition is head to tail. Head to tail, okay? So I'm not really showing that to you very well, but if I have a vector here and I run it this way and I want to add another vector, then I put the tail of it and I go this way. So the result is right here. That's the result. So here's vector 1, and this is vector 2, and here's the result. Okay, so if I add vector 1 and vector 2, I take the tail, go to the head, put the tail of the second one on, go to the head. Now, and then I start at the original beginning and go to the head, tail to head. If I want a negative vector, then it's just going to point this opposite direction. It's going to be the same length. So there's a little bit of intro to vectors.